We are live, at least the platform is saying that. So hello everyone. I hope that we are live. That's the mantra of every webinar. So just say hello. Say, okay, we hear you. There are no problems. I will check the YouTube and I will, okay, YouTube seems to work and Facebook also seems to work. So technical checks are behind us. So hello. I'm super excited. We have today me and Szymon. Hello, Szymon.
Hello, howdy.
So if you are hearing us well, we are going to the next slide. And in general, welcome in the webinar, which is something that was in my mind for many months, because maybe you know me, maybe not. I will present few words about me, but in general, I'm talking a lot about .NET GC, and there is often so many discussion about, okay, but why I should care about it at all. So that's the idea of it, and I will really try to convince you why it is worth to. I mean, we will try to convince you why it is worth to care about .NET GC and memory management in general. So let's move on, because we are only on the first slide and we have 67, so probably we should move on. So just as a kind of author of this webinar, as the idea of it is from me, let's just present the second host today, which is Szymon. Hello, Szymon, and again, if you could say a few words about you, it would be awesome.
Yeah, I never allocate before noon. I do other things before noon probably, but not allocation stuff. So yeah, the shortest summary.
We don't like So as I even presented on this graphic that I made for this, I will not allocate memory at all. So you don't allocate before noon. That's pretty okay. Okay, so that's Szymon and that's me. So I'm a kind of .NET freelancer, trainer, consultant, speaker, living in a .NET ecosystem, living from the .NET ecosystem. I'm an author of Pro.NET Memory Management book. We, with Szymon and Łukasz, are co-founders of this initiative, which is called .NETos, which is all about advanced stuff in .NET. And we organize various things like conferences, webinars, and online courses. If you are playing games, there is out of memory card game. You can go to that site and maybe eventually it will be published. We will see. Okay, and I am author of this book. As I said, it is 2 kilograms, as you can may see on the slide. It is already translated to Polish and Russian, and as far as I know, it is also being translated to Chinese currently. Maybe it will be finished in a few weeks even. So yes, 2 kilogram of pages about .NET memory management. So it seems that I have and I had something to say about it. But again, why should we care about it at all? 2 kilograms about something that is totally automated. We will see. We will see whether we will be able to convince you. One of the things is that feel invited to ask questions about everything, like about me, Szymon, our approach to .NET, but in general, mostly about .NET memory management and the idea which will be presented here, whether we really should care about it or not. And I'm doing a lot of stuff regarding .NET and .NET memory management. So recently I started to do those infographics, which is about some pretty niche, interesting stuff that probably you should not start to use since like from tomorrow, but I believe that it is pretty interesting to see such stuff. So you can find us on the Twitter, for example, to have a look at those infographics too. And also I made, since the beginning of the year, this series. It was kind of mini series about .NET GC internals, but it ended in 10 videos, which is in total something like 14 hours of materials about how .NET GC is working internally, which is not so super practical. Like, obviously there are some super nice findings, but it is a lot of knowledge how it really works underneath.
Yeah,
So
I think that I can follow the mantra. First, the size of the book, and then the mini series with the webinars. So
yeah, everything is
definitely
growing.
you have something to say about this topic.
Yeah. So 14 hours, 1,000 pages, and now I'm preparing .NET Memory Expert course because I believe it is so interesting topic. You may be interested, and I will present more information about this course also at the end of this webinar. So even also, if you have any questions about it, do not hesitate to ask, and I will try to answer. So in general, feel free to ask questions, discuss, elaborate, give us any kind of feedback that you are there and listening and you agree or maybe not. Also, if you are willing, so you can say from where you are. It is always nice to see that you are from various places all around the place, all around the world. We are from Poland, from Warsaw, and also almost from Warsaw, like Szymon is living near Warsaw. So after this short kind of introduction, the first main question: why should I care about .NET GC? This is the title, and in general, why should you care about .NET GC? So this is the question for you that we will try to answer. And in general, it is kind of why should you care about learning and understanding tools you use. I believe it can be rephrased like that. Why you, for example, should care about async or await, which is nice thing introduced in .NET and in C# that allows us to write scalable applications, reusing threads in some magic ways. Why we should care about how it works, I don't know. Why we should care about database, whether it is a flat list of records that we can take data from and put there. Maybe it is something like that, and we should not care about thinking about database a lot at all. Or maybe you don't think about object relational mapping. Like, we have entity framework, and it is a magic box that is supporting get me data, put me data, and that's all. And the story obviously continues. So in the end, what you need to know when you are programming, whether it is approach that you are trying just to make a Jira task being completed by filling few lines of controller, or maybe you really need to try to understand a little bit more to, have this feeling that you are doing what what you are doing. So this is, I believe, good thing. And all those things that I've covered, like async await, for example, and obviously .NET GC, and in general, automatic memory management is a very convenient abstraction. I like this word abstraction because it is. Like the abstraction, as the Wikipedia says, is a simplification of something much more complicated that is going on under the covers. So we have something complex that is doing some magic, and now above it we have an abstraction that is simplifying our life, providing this abstraction to make our life easier. So for sure, as you can see, .NET GC is pretty well fitting this abstraction thing. Like, it is a simplification of memory management. So it is a promise that you have in the end infinite amount of memory because you can only allocate, and you really don't care about releasing resources. So magically it works, like you newing up things or constantly newing up new things, and you don't have this delete operator and anything like that. So you are only concerned about putting more memory pressure, and then this nice abstraction is working for you. So I like this abstraction, right? But this is not the end of the story, because all abstractions are not a magic in the end. It is just a technology like everything else that we use. So, for example, Joel Spolsky, which is pretty well known, I hope, person in the IT, which is a co-founder of Stack Overflow site. Do you know Stack Overflow site? And maybe you know. And also creator of Trello. As far as I remember, Trello is pretty nice tool also for managing project, for doing any kind of organization stuff. And he pretty a lot of years ago, even it will be almost 20 soon, he coined this the law of leaky abstractions. Maybe you heard about that, maybe not. I really like it, and I'm also always referring to it when I'm describing stuffs like that, which is pretty easy to phrase. Like he said, all non-trivial abstractions to some degree are leaky. So we have this pretty nice abstraction, but simply this abstraction in the end will somehow leak. He provides an example of this TCP. Like TCP is super nice protocol that is providing us this nice abstraction that you can provide any information in a reliable way to a different party, and that's all. But it is working on an unreliable protocol, which is IP, which is like trying to send packets somewhere to the void and hoping that we'll reach the destination. And then we have the whole mechanism of retransmission, flow control, buffering or to provide the message in order at the destination place. So now it's nice abstraction, which in the end may hit us, like it may leak, because then we will start to think about retransmissions and other stuff that may influence latency, for example. He was describing this particular example, but we have a lot of different ones. For example, object relational mapping, like I will return to this, is hiding as SQL queries in the end, and the whole relational database in some way. But if any of you has ever used Entity Framework and Hibernate or Entity Framework Core, for sure in the end it ended in analyzing what exact query has been used by this magic code, because you want to optimize it. So it is a nice abstraction. Yes, in the end it helps us, but it is not, it leaks. Like you will be eventually sometimes interested what's going underneath, what the SQL query has been provided, what was sent to this database, and it will leak more or less seriously depending what you are doing. Or one of my most beloved examples, if you were ever using ASP.NET Web Forms, there was this super nice abstraction that it is just a desktop in case, like working in a stateful manner. So it has, because it can still be used, a state, and your site out of the magic has a state. Like any other desktop application. But HTTP protocol, which is used for serving web forms, is state doesn't have state. So this abstraction was provided by our beloved view state. Like we love view state. If you have ever used web forms, probably you've seen view states that were big.
Yeah, it reminds me the meme where there was the Enterprise starship, I mean for the Star Trek fans, and the other part of the screen was like a huge Borg cube in the middle of the space, and there was an arrow pointing. That's the view state of your page. So yeah, definitely, probably everyone who ever used view state make it a bit too big at least once in their lifetime.
Yeah, and it was out of the sudden surprise that your page weighs megabyte or two, although it doesn't contain so many data. So yeah, that was pretty the thing, like nice abstraction that lives somewhere and just tries to beat us, bite us, and a lot of different things. Like we will not, because we have our beloved abstraction for today, which is .NET Memory. So I would say abstractions fail. We are pretty often fooled by abstractions. Sometimes they leak more, sometimes less, but they can bite us. But then for sure someone will say, okay, but okay, there is this .NET GC, it is automatic memory management, and in general, I've been programming in C# for 1 million years and have never needed to care about it. For sure, there are some voices like that. And obviously, I'm trying to be funny here, but it makes sense. Like this is pretty valid voice because it means that this abstraction works. Like uh, obviously abstractions fail, they are leaking sometimes, but in general they are for making our lives easier. So if someone says like that, I'm working in C# for 10 years and I don't care about .NET memory, it means it is a pretty well work done from the .NET team that it is working nicely. But also I will think, okay, but are you sure you are not leaking any abstractions then? Do you measure it? How do you know it is working well? If it like working is not working well, right? You can make something working by using 1000 gigabytes or 1 gigabyte. I don't know. Yeah, well, I need to measure whether to know whether something is optimal or not. But in general, coming back to this abstraction, we have that's why this 18% rule works, like the Pareto rule. Most of the time, you don't need to think about it until you need. So there will be some scenarios that you will be interested, and there will be a lot of different scenarios that you will be not interested because this is a nice working abstraction for you. So yeah, you don't have to care about it until it becomes a problem. It's a kind of mantra that you can also meet when discussing things related to .NET GC. We will return to that because let's stay for this 18% rule for a moment. So yes, you can be in this pretty big part of this cake, the 18, 19, it depends, percent of people that don't care. And that's totally fine. Your projects will work, you will earn money, and you will be happy. But then it is this 20, 10, 5, it depends, percent of people that maybe will care. And they will become people that are aware of how it is all working. And they will have this label of experts because they will be handling those scenarios when this abstraction leaks. And you need to more deep into it. You need to learn more to understand it. So the mileage may vary in which group you will be, in which group you want to be. If someone says like I have been programming in C# for 1 million years and I have never needed to care about .NET GC, that's fine. That's this person perspective. But I can make an opposite question. If this person would be thinking about .NET GC, what this person would be working on currently or during those years? Like it is kind of, you can change the perspective. Maybe this person was working on projects like that because it was not caring about .NET memory at all. But if it was or she was taking care about it, maybe this person would be working in more interesting projects. Simply, we use this word, more interesting projects. Maybe their projects were just boring apps, like maybe they were not measuring whether they have problem or not. So for me, what I'm trying to say, this argument that I've been programming in C# for 1 million years and I don't care is not so strong. Like, okay, but that's your scenario. From my perspective and from the Shimon's perspective and from many people perspective that I know, it is not such easy thing. And there is always this question, okay, so do you want to be an expert or just a kind of regular developer that just don't care and is not knowing anything about the things that it is using, she is using? And that's your choice. Like, your image may vary. I will not try to convince anyone saying you must to do that, but I'm just trying to say that it is worth to consider doing that. It is just for you to make a decision. And moreover, there is one more aspect of it. So we can look at all of it from two main perspectives, like because it is always constantly returning, and it is really nice voice here, and it needs to be said that all of it that we are describing here can be seen from two perspectives. Like, the very first one, the most common one, is application developer perspective. So this is most typically with that you are probably relying to, comparing what I'm saying to your own experience, because most of you probably are application developers. So from your perspective, this is a nice, probably good approach. Like, if you want to be just this kind of regular .NET developer, this approach, you don't care, is fine. But there is this next level that you can try to take, trying to be an expert, trying to be better well paid, trying to be invited into more interesting projects. And then you need to start to learn, understand. We'll return to that. But in general, when you are an application developer's perspective, from this perspective, you are in a pretty nice position, because you know your app, you know your workload, you know your clients, you can measure things, you can you know the requirements, you can measure everything and fine tune your application to the current needs or to the expected needs. So this is when this all knowledge may lead you to. In general, you don't need to write everything with the help of pointers and span and memory and stackalog, unfortunately, sorry, because you know your goals. You know that you need to serve 1,000 users per second, for example, or 10 or 1 million. And then you will know what tools should be used for that. But keeping in mind performance, good and bad practices, being aware of those abstractions that where they may leak, knowing how are your entry points if you will need to measure something, how you should approach that, what tools you should need to use. This is a whole area for being an expert on that field, and I really, really believe everyone will benefit. My whole career is benefiting from that fact, that I just wanted to know more, and people started to come to me with questions. I started to answer them. So there were more questions and there were more answers. And in the end, I have this book and this course, and the whole things are happening. More money, more money is coming to me because of that, if it will something that may convince you. So be an expert. That's I really believe it is worth to do that. There is this second perspective, also super nice, that maybe you are, or maybe you are thinking to be a library author, a NuGet package author, whatever. And then you don't know how will be using and how your library will be used. So then there is no sky limit for the performance of your library. And we can see even now that when you are looking for various libraries in .NET ecosystem, like choosing, I don't know, JSON parser, a classical example, or maybe you are looking for a library that will parse you your Excel file, or maybe you need to transform Markdown to HTML. I don't know. There are many libraries, and people start to find better one also in terms of memory usage, in terms of performance. So when you are a library author, you look at C# code from various perspectives. You really don't know your customers. You don't know the client. You don't know the context in which your library will be used. And if you are kind of good programmer, software craftsmanship, you will try to provide as good library as possible. And then all this stuff like pointers, spans, yeah, that's something that probably you will be starting to be interested in. I'm not saying it is from the point from which you start by stack allocating everything. That's not what I'm trying to say, but it is the context in which high level performant code is much more likely.
Yeah,
So
I totally agree. Especially you mentioned all the NuGet packages, libraries, and that in my from my perspective that starts or maybe already has become a selling point for a library. Even sometimes you just make the comparison and the benchmarks are provided in there. And what you do is that you will choose the faster one, even if it has some limitations, because of course, with the speed, sometimes you need to narrow the case, but still you will choose the faster one, or the faster one will be more popular because of the fact that it will use less resources and basically will be the faster one. So yeah, totally take and agree on this point with you.
Yeah, so it is a really important factor currently, and you will be more popular as an author of more performant, well-behaving library. Like, it is one of the really important reasons why and how people compare things. So bonus question for
some people may try to leverage and just let's write a extremely poorly written leaky allocate the app or library, but I hope that's not the case.
Yeah. I hope everyone takes it with a little bit of right. So bonus question for you is in general, and the kind of message from this slide is also for you to think whether you want to consume .NET libraries all the time, or maybe you will be willing to produce them, produce the reality that people are using. So I'm not saying that you need to immediately think about working for Microsoft on .NET runtime, but there is so many popular libraries. Most of them is open sourced. Some companies are paying for maintaining open source stuff. So a huge amount of possibilities on that field. And I believe you can only benefit from doing that. So, and for money, obviously, the best thing is. There will be sometimes also arguments, okay, but if you are taking so much, taking care so much about performance, then we have C++ for that, or we have Rust for that. Okay, point taken, but I'm a C# developer. I want to earn money from being a C# developer, and I believe .NET ecosystem is huge. And C# is so multi-level language, in fact, that you can write high-level things there or low-level things there. .NET Runtime really supports a lot of low-level things. So why we should move to C#, like C++, sorry. We can, but I'm not C++ developer. So I'm not taking this argument as a definitive one. So in the end, why you should care about .NET? Even someone said, as I saw on the chat, knowing more is never bad. Like, I don't imagine being hurt by knowing something more than less. Recently, I was preparing a Blazor talk, and Steve Sanderson is an author of Blazor, which is also an author of Knockout JS, which is, by the way, I really like that library. I was using it. And there was an interview with him at some site, and there was a question, what is your one piece of programming advice? And I decided to use this because I really like the answer. So he said that when something isn't working or behaves differently than you expected, don't just keep changing things until it seems to work. Like, try to understand. As a lot of developers sometimes try to do, adding this or that, or maybe copy paste something more from Stack Overflow. His advice, and this is one piece of programming advice that I really, really, truly agree, make sure you figure out why it was doing what it was doing. Like, try to understand what it was trying to do, why it was doing that. Because otherwise you're really not advanced in your skills, and this is approach that you really need to take, and it will be beneficial no matter whether you are C# programmer, Rust programmer, whether you are writing ASP.NET Core, whether you are in architecture or .NET GC, it doesn't matter. This is just, I believe, super nice piece of advice. So thank you, Steve, by giving this advice in the interview. I really like that. And by the way, speaking about understanding things, there is this super nice mechanical sympathy movement idea, however you call it, and that I'm always also referring to when talking about high performance and understanding things. So maybe you have met this quote or maybe not. So mechanical sympathy is a quote of the Jackie Stewart, which was a racing driver, and he was asked about what makes a good racing driver, and his answer is that you don't have to be you don't have to be an engineer to be a racing driver, but you do have to have mechanical sympathy, a little bit of understanding how this car is working, how the engine is working, how the gears and all this stuff underneath is working. Not to be a fully, mechanical engineer that will be able to repair every car on the planet, but have this mechanical sympathy to understand what is going on underneath. And Java champion Martin Thompson, Java champion on .NET Webinar, author of Aeron, Disruptor, and in general well-known person in the high performance code and in general high performance field, incorporated this quote to the needs of the IT. So he said exactly the same. Mechanical sympathy in case of software engineering is exactly the same. You don't have to be a runtime engineer, for example, to be a good software developer, but have kind of mechanical sympathy to understand how things that you are using are working. And also returning to Joel Spolsky from this classical article, he has the very similar advice. So returning to this leaky abstraction concept, the only way to deal with the leak, like not the memory leak, but the abstraction leak, is to learn about how the abstraction work and what they are abstracting. So as you see, and we could repeat this many times, a lot of wise people in the IT industry is trying to convince us that understanding how things are working is just beneficial to make you a better programmer, to move you from this level of trying to use things to move you to level of an expert, a software craftsman, a person that will understand and benefit from understanding. And speaking about all that, we believe there is a huge space between those two approaches that we can meet. That pretty often we can meet this approach. I don't care. I don't know anything about the performance. It just works. I get my money and I'm going home. Between this approach and the second one, which is sometimes provided as an argument that not everyone needs to be like that. And the second approach is, I know everything. I know every pointer in the runtime, and I'm sleeping with the book of the runtime under my pillow. And in general, I'm writing only hyperv code because I'm writing a game engine or any other super advanced stuff, which requires low latency and so on. There is so huge gap between those two approaches. And then I would like to propose, and I really, really believe in this pragmatic approach to .NET memory management, because returning to the previous slide, I believe people sometimes are just thinking that when I'm showing something about .NET GC, they immediately treat me as this group, like, oh my God, you are showing something about .NET GC, you must be writing a game engine, or you are just developer doing some super high trading platform or so. No, there is a lot of space between those two approaches. So the pragmatic approach that I really believe in is that there are some levels. Like there is level 1, and every .NET developer should live there. Level 1, obviously I'm omitting level 0, which is about I don't care and I don't care. So level 1 is a kind of level of programmers that they treat performance as a small addition to just clean code. Like they have in this kind of gut feeling about what is really low hanging fruits that you can avoid or take simply to avoid big problems, or at least don't do stupid things by default. Like you can consider using struct here or there. You don't use link on hot paths. You know how the list is working, and you know that there is such a thing like capacity. So no magic. Like I'm not saying that level 1 people should be living with the reference materials about pointers and what the ref struct is, but there is pretty a lot of knowledge that is not hurting anyone to avoid some common pitfalls. And there is a lot of talking about clean code. I believe performant code also should be added here as a kind of sanity check when you are doing something. You don't need to think about it for hours. Just set of advices. Then we have level 2, which will be going into this expert zone, like trying to be more and more expertized in the field. So for example, how to measure things, how to diagnose those things, to check or to check whether something bad is happening, to find the reason if something bad is happening. So then you will not need to know a toolbox, some tools, how to use them, where to use them, and so on and so on. Both those levels require also kind of knowledge about those abstractions. I'm not saying you need to know and cite from memory all 14 hours of my .NET GC internal series. It is not the goal here, but some knowledge about those abstractions, and mostly on these particular fields, then they tend to be leaky, is really nice to have on those two levels. And obviously then the level 3, which will be about more advanced topics and tips of C# usage, when you really are thinking about writing memory-aware code, which is really high performant, optimized. It will require probably more and more internals. So I believe those 3 levels are 4 levels, because we have also level 0, are for you to be. You need to choose like where you want to be. And I believe by going higher and higher, you can only benefit. I'm also personally not paralyzed by the hyperv code. So when I'm writing something, I'm not spending 1 hour thinking whether this should be class or struct, or maybe I should stack alloc something, and then I'm just being afraid of write any line of code because probably it will be not performant. No, I'm just starting to write working prototype, something that works, something that may be checked whether it makes sense or not. And with this gut feeling that you have after some time, you will be just identifying some common pitfalls that you can avoid at the very first, and then also to know where are the fields of possible future improvements. But not being paralyzed by this afraid that hypercode will be not created from the very first keystroke. Obviously, then we need to know how to measure, how to optimize, what to optimize, where to optimize. To avoid those stupid, let's say, call it stupid mistakes, like calling link on hot path, reading with the help of entity framework, the whole table from the database, and then filtering with the help of Linku. A lot of very different, quite basic things may be avoided when you know about them. And I really believe that when we are talking about clean code, that is, what is the goal of clean code? The clean code is just to make better code in terms of maintainability. We want to write code to maintain it better because someone else will be reading it, someone else will be modifying it. So this is the goal of clean code. And the goal of performant code may be a different one, like we are writing it just to make the code better in terms of resource management, in terms of memory management, CPU usage, in general, to host it better. And I really believe in this software craftsmanship movement. Maybe you are aware of it. And one of the points of it, as far as I remember, the first point of the software craftsmanship manifesto is to write not only working software but also well-crafted software. So the fact that something is working is not satisfying for a software craftsmanship. We like to write well-crafted software, and I would put here performance as one of the points satisfying the fact that something is well crafted or not. If you are aware of it, obviously, not that every code and every single line of code needs to be performant from the very first beginning. Just being aware of it. So, by the way, this webinar is obviously about .NET memory management and GC, but I really believe this applies to everything, whether it is architecture, async await, and how it consumes concurrency, databases, .NET runtime itself. This could be applied for everything. But this is obviously a webinar about .NET GC, so I really believe all those levels and the code being well crafted in terms of the .NET memory management makes sense. I believe, at least. So one example, because it is about .NET GC and C#, so we need some example, practical one, let's say. And example of leaking abstraction. Very common one, like I'm presenting it for years, but I hope you haven't seen it yet, so it will be new to you. There is an abstraction that memory is automatic and it should be treated as a flat space where you put bytes and get bytes from there, and that's all. But if you make a benchmark using a beloved benchmark.NET library, and by the way, you need to know about benchmark.NET library and how to write well-crafted code to use it, then you will be able to compare how it behaves when you access some big two-dimensional array by rows or by columns. So super classical example. In this example, we create a 5,000 per 5,000 integer two-dimensional array, and we are just setting 1 to every element of it. In the first case, we are doing it element by element, row by row, and in the second case, we are doing it pretty strangely, like by column, like not sequentially. And this code is super similar next to each other, like it is only the difference in what order we are accessing memory. And if this abstraction is working, then it should be the same performance. Obviously, it is not. So if we measure it, and I invite you to measure it on your own computer. By the way, slides from this webinar will be published later on, so you will be able to copy paste or click links and so on. So if we measure it, we will see that the column pattern is 10 times slower, just because we are accessing memory not in optimal way where we are accessing them element by element, but in kind of almost random way, like trying to access some elements column by column. And now we see that, okay, so this abstraction really leaks, like our code becomes 10 times slower just because we are accessing the memory in a not optimal way. That's pretty sad. And so many abstractions leaks here, like I mean, those implementation details are leaking here. Like there is a CPU, there is a random access memory, but in between we have caches of 3 levels, and moreover there is a cache line, which is a building block to access memory. So a lot of internal stuff needs to be understood to understand why this difference is so big. So, okay, this memory abstraction is leaking, and as you see, .NET Runtime doesn't handle it in any way. Like .NET Runtime is pretty high-level stuff, and we could expect some magic from it. But in the end, it is just the whole thing leaks, and the implementation detail of the CPU is simply hitting us here by 10 times slower code execution. So, for example, knowing, sorry, how to optimally access memory will be called data-oriented design, and it is pretty nice set of principles and patterns how to write code from the perspective of the data access to make it efficient. Okay, that's pretty big stuff for example, game engines and other super magic high performance code. So probably at this point, looking at this webinar, someone will say, okay, but Shimon said that because someone needs to shut out it.
Yeah, so premature optimization is the root of all evil, of course.
Yes, no, yes, obviously. So sorry. So all this doesn't make sense. So this, if I could take, if I could only get $1 for this quotation being misused, I will be really rich. Like it is so often taken without the context that premature optimization is the root of all the evil. So I decided to put the whole context around it. So in general, just to say it for once, and probably it will be just again repeated and repeated, but premature optimization is the root of all evil. Evil is a quote from pretty old paper from Donald Knuth from 1974, which was about go-to statements, by the way. So if you like go-to statements, you should read that paper. But he presented some elaboration about the fact that this particular algorithm can be improved in terms of performance by using go-to statement or so. And that's not the important part. The important part is the whole context of this quote. So the premature optimization is the root of all evil. Okay, but then we have the beginning of the surrounding text. Like for he's saying that the presented improvement is only about like it improved by 12%. And many people would pronounce that insignificant. So the conventional wisdom shared by many of today's and 60s software engineers calls for ignoring efficiency in the small. So most programmers, even at those times where computers were weighed in kilograms and there was speed of megahertz, were saying we don't care about such small inefficiency. That's pretty funny from our perspective. But I believe this is simply an overreaction to the abuses that they see being practiced by penny-wise and pound-foolish programmers who can't debug or maintain their optimized programs. So okay, so there is a bigger context. Like most programmers complain that this kind of optimizations doesn't make sense because they are overreacting to some other worse programmers that are not being skilled enough to make such optimizations in a good way. Like there is this penny-wise and pound-foolish description. So they are caring a lot about the details, but don't see the huge picture, and the overall result is pretty pity. So there is bigger context. And then he elaborates, but in general, I believe 20%, 12% is pretty nice improvement. And I would be afraid of not taking this chance if I could. I don't want to restrict myself to tools that deny me such efficiencies. This is the whole context of this unfortunate quote. So, yes, the most important part is, and the introduction to this quote is, we should forget about small efficiencies, like say about 97% of time. Premature optimization is the root of all evil. Yet, and no one quotes that, unfortunately, we should not pass up our opportunities in that critical 3%. I don't know why people are not citing that.
I mean,
Moreover,
that contradicts the message from the first phrase. So that would be really unhelpful to convey the message that you shouldn't care about it, and
but
then if you add it, it's just diminishes the first part.
I believe it is not shit posting enough with this context. And moreover, a good programmer will not be lulled into complacency by such reasoning. He will be wise to look carefully at the critical code. So please believe me, there is more than just this simple out of the context taken quote. So in general, don't be such kind of programmer. Optimizations, probably we fully agree, like optimization for millions of users when you have a company that handles 100 customers doesn't make sense. Like it is premature optimization for sure. But always remember about this critical part. There is this critical part that you may be interested in future. And moreover, as he said, good programmer will be not super satisfied with this citation that I don't care because premature optimization is at the root of all evil and that's all. That's not the approach that Knut was presenting. Like, be aware of inefficiencies, be aware of all those 3% of edge cases, look around, be careful, but don't waste time where you shouldn't waste it. So sometimes I read this, quoting this as kinds of explaining the laziness. So I'm lazy enough not to care, so I have a quote and now I'm totally covered. Like I don't need to care because Knut said so. But also there is this difference. If you are an expert, if you start to think about it, if you gain some gut knowledge about all this stuff, it be just your experience, not supervised thinking for hours and premature optimization. You will just know what you should avoid, period. It doesn't take huge amount of money and time. So always remember about this context. About avoiding these common things, trying to understand a lot more where are possible leaks of the abstractions and so on. Another example is this application, and it is a web application that was measured with the help of performance counters. And what we see here, for example, we see that, and we need to know about generations to understand this graph, but okay, assume that we know what generation is. So generation 0 size was like 1.5 gigabytes. This is for measurement like for 5 or 6 hours. It seems pretty stable. So, okay, 100.5 of gigabytes is a lot or no, I don't know, but it is at least stable. Then generation 1 size is pretty unstable, but it is within pretty small range. So I don't care. By the way, if I know that generation 1 is a temporary one, intermediate one, it is the behavior I expect. It is floating pretty dynamically. Then we have generation 2, which seems to be pretty big. Like we see that it takes from 15 to almost 27 gigabytes of memory. And then we can start to think, okay, whether it is good or not to waste some memory for handling this. You need to understand what is your traffic, whether you are satisfied with such memory usage. Moreover, you see those pattern here that occasionally we have huge drops of memory usage, like 5 gigabytes or even more gigabytes of memory is being fed by the GC. But the baseline is constantly growing, I would say. So I will be a little bit afraid. whether this graph is good or not, do you know? I don't know. It really depends on the context, and it really depends on your understanding. Then there is large object heap size, which is also pretty big. Like we see that it is up to 15 gigabytes, and we also see those drops. So there is an increase of memory usage, and after some time there is a drop of memory usage, which probably means the GC kicks in the full GC and reclaims memory in large object heap. If you have this gut feeling, you know that large object heap is for pretty like not so many things being there, and 15 gigabytes seems to be pretty much. So you will be interested why this particular application is using so big amount of memory. If you add those values, you will see that your app will start to use like 40-50 gigabyte of memory. Okay, memory is cheap if you are buying a laptop, but if you are hosting a financial app that needs to be certified and needs to be hosted on certified hardware with the company supporting it, believe me, every gigabyte is a cost. If you are hosting it in cloud, the same story. So then we would like to investigate it. How to investigate it? With what tools? How to approach the investigation? What to look at? This is the level 2 or 1 of this level of knowledge that we need. So when we look at it, we will see, for example, that large object heap fragmentation is like 80%. So we have 10 gigabytes of memory. Like in this particular session, we have 1.5 of gigabyte of memory in the large object heap, but 18% of it was empty. Like we were paying for 1 gigabyte or more memory, which are just zeros. Why we are paying for 1 gigabyte of zeros? Why the fragmentation is so big that we have 18% of free memory there? Or generation 2, which is also 10 gigabytes in this case, and half of it is empty. So we have this, we are paying for 5 gigabytes of memory for empty space. If it suits you, okay. If it suits your company, also okay. For me, it doesn't sound like software craftsmanship. And we need to start to understand why it's happening, what tools you should use to diagnose it, to understand what's inside, and so on and so on. So this is pretty strange for everyone that have this gut feeling about .NET memory management. If you are at level 0, you will say, nice colors. Where is the coffee? In general, this is not the software craftsmanship that I believe we should take. So a lot of fragmentation. And what was there? So in general, if we see something like that, you may know that probably it means there is a lot of temporary objects being allocated and then dying. So why they are dying? Why we have this approach that a lot of objects is being promoted to generation 2, and then it dies because there is a free space. So it means objects are dying in Gen 2. But this is in contradiction to the whole generational hypothesis of the generational GCs. We should not promote things to Gen 2 only to die there. Maybe it is a problem of cache. Cache, unfortunately, is contradicting the generational hypothesis, because we are promoting pretty a lot of data eventually to generation 2, because probably it has times like 10 minutes, 15, 1 hour, and then it dies. So maybe there was too much cache being stored in memory. And the large object heap, like 15 gigabytes, strange. Maybe we have too much buffers or processing huge amount of strings. What we can do about it? Solution was pretty easy. So if you know, your first idea may be, let's look what is being allocated in large object heap. Okay, it seems that they are byte arrays. Let's replace it with array pool, and then you don't have hundreds and thousands of arrays being created then because you reuse the same bytes arrays again and again. or you will be able to use tools to see what is being cached, and you will, for example, be able to cache less things, or maybe you will move it out of the heap using Redis. It really depends. But you will be knowing how to approach the measurements, and you will be knowing what is not so good with this app to know whether you really need 50 gigabytes to host the application. And I like this example because so many abstractions leak here. Like you can understand a little, but in general, to understand the whole picture, and moreover to investigate it, because I presented you some graphs and some solutions and findings, but to investigate it, you know to things, you know to you need to know things, like you need to know that there is large object heap and big arrays are allocated there. You need to know the generational hypothesis and what's about Gen 2 and how it should behave. What full GC should what full GC should reclaim and how often. You should know that concurrent GC in .NET is not compacting, and that's why you are seeing this fragmentation. You should know that .NET process is not freeing fragmented memory, so then you are paying for gigabytes of empty space in the end. Huge amount of abstractions that are huge amount of leaks of this nice abstraction of memory management. This is only an example, obviously. I could show you huge amount of examples. There will be many examples like that in the course. There are examples like that in the book. But I believe it's not the goal. Like even 10 examples presented today cannot convince you, because you could say, okay, but this is this example, this is the particular case, this is using this library which is no longer used, and so on and so on. So not the particular case is important here, but the overall thing that this is an abstraction and we will always leaking, no matter what tools we will start to use, what libraries we will be using in future. So in the end, I believe level 2 is the best, like how to measure the thing, how to interpret the results. Okay, a lot of talking. So it was a lot about you. And now add little bit more context about your company, because probably you are working somewhere. I don't expect we have a lot of CEOs here today, so probably your company is just the company that is paying you, not that you drive. But let's look at the company perspective for a moment also. That's the company perspective I often perceive. So we have a lot of money, we don't care. And somehow I may agree, like, okay, build fast, make it working, burn money as long as it makes more money. It makes sense. But every time that you will meet something about performance, you will immediately find a lot of important reports how performance is directly translated to money, not in terms of the resources usage. This is the one thing, but also from the user's perspective. A huge amount of reports that even 100 millisecond change in the responsiveness of your site is directly translating to conversions. And this is one of the examples of the report from Deloitte, that they observed for 4-week period of time some pages, and they observed that even a small percent of like 100 millisecond change in the performance of the site was reducing conversions by 10%. And it is only 100 millisecond change. And there will be another reports, a lot of such reports. So if the company where you are working is not convinced because they don't care about spending money on the processors, cloud hosting, for sure they should be concerned about the responsiveness of your application, because we are really used to fast applications, and the performance really matters, and it is an important factor when people are choosing platforms.
Yeah, and we are not encouraging you to convince to just show your companies how bad it can get by introducing a lot of allocations and just making the app slower. We are trying to make the opposite statement.
Exactly.
Just by making them better, you will earn a lot of traffic, and as it's mentioned in this report, a lot the increasing conversion rates.
Yes, and this is especially in the context of mobile commerce, because more and more people, not even commerce, but in general, more and more people are just using internet through mobile phones, and they are really limited in terms of resources also. So another reason to look at the performance, and this is also argument against argument that okay, but hyperperf code is only for game engines. It is not. Like, we are writing our boring line of business app and we don't care. No, you care, because there is at least 10 companies providing exactly the same line of business application than yours, but probably they will try to fight with you at the level of prices, at the level of features, at the level of performance too. So there is no app that should not be not concerned about performance at all. So from company perspective, and I'm talking about that also because when showing any hyperv code, those infographics somewhere in the internet, there will be also those 3 mantras that I will present today, which is kind of company perspective, but speaking on behalf of companies by individual developers. So the very first mantra will be, infra will take it. We don't care. We will put as much money on it as it needs, and we don't care. And as I said even before, I agree. Sometimes it is just good, especially for startups, because probably startups needs to provide features and look around whether they have customers, not to optimize this particular method to be 1 millisecond faster. So spending more money on Azure hosting, for example, than paying for an expert may be a wise choice. But in the end, it will be, or luckily, it stops to be a startup. It starts to handle more and more traffic, and performance is in general a feature. So it needs to be added. It's not something that is out of the box. It needs to be considered. It needs to be planned somehow. And by the way, you don't know if you are overpaying for something if you don't measure it, if you don't know how to measure, what to measure. So for me, it is okay. I understand this argument for sure.
Yeah,
but not in every context.
I think it's worth to add that with the modern movement of measuring more, and I don't mean like even developers that work on the business line apps, but I mean like from the providers and platforms. Now you can measure more and more, and you can see the performance of a specific function. I think that it's quite likely that we will get to this area that you will be able to tell, oh gosh, that Azure function is really shitty, and we should make something about that because it consumes so much money that it burns everything, like in the meme that Conrad provided. So totally agree on that.
Exactly. And maybe for some it might be kind of point that maybe we should also have this a little bit of ecological sympathy. So more and more companies, probably the most rich ones, are starting to think about the being carbon negative and not consume everything because they can. And when you optimize something to use 100 megabytes instead of 1 gigabyte and you put it on cloud, it really will change a little bit difference for the planet also, or however wise it doesn't sound. The second mantra is also stated before, we have C++ for that. I'm pretty surprised that a lot of C# developers are saying that, like, okay, we can put some code and this 3% of the code can be the critical part of the app in terms of perf can be in C++, but why should I care as a C# developer to put something in hand of C++ developer? And moreover, from the company perspective, I'm a .NET. Let's say I'm a .NET driven company. I have teams with .NET programmers. I have the whole pipelines and whole IDEs and ecosystem. Um, I am .NET based. So why I need to introduce C++ developer to make 3% of my app? Why I can do the same in C#, staying with the same ecosystem, with the same B pipeline, and so on and so on. So this argument makes sense for sure, but I don't buy it so much. And your mileage may vary. Maybe you or maybe company wants to introduce one guy C++ developer to the whole bunch of .NET developers for maintaining a part of the system, but it needs to be considered for sure. And there are some companies that are saying simply, we don't care, it works. But if they think so, I really strongly would say to them, although probably no one is listening to me from such companies now, look for reports like milliseconds make millions, and so on and so on. Try to understand how important is the performance, not only from the resources management, but from the customer perspective, how the performance directly translates to your customers. But for you, the most important is we don't care. Like, you don't have your own companies probably. Just sell it, like become an expert, whether it is on an architecture, scalability field, performance field, .NET management field, all this connects all together. It waits for you. I believe all of you can benefit from that just by being a little bit higher level than let's say regular developers that don't care about all that stuff. It really waits for you. So the question is how. Like we are all both 1 hour, so the question is how you can start to learn about .NET GC in particular, because this is the topic. So a lot of free stuff there is obviously available, like Mauni Stevens, which is the maintainer and main lead developer of .NET GC, has this really nice document about .NET memory performance analysis. It contains a lot of knowledge, but a lot of reading, which is super nice, but you need a lot of time to consume it, let's say. There is also a lot of obviously documents about garbage collection design. For example, in the .NET, in the book of the runtime, there is this mini series about .NET GC internals, which is 14 hours. There is .NET GC tips and tricks, which I started recently, which will be about those things like the title says, some tips and tricks, how to move in the .NET ecosystem in regards to .NET GC. Obviously, you can follow a lot of wise folks on Twitter, like Maun itself, Ben Adams, and other. But then there's the topic, like I would like to say also, which is the course, because I saw also the questions on the chat. After writing those 1,000 pages, I really wanted to write something which is more interactive, more for people that prefer watching than reading. And it was my really nice to have thing to provide the .NET Memory Expert online course. And this is exactly what is happening, because we started under our .NETOS brand to pre-sale it from today, right, Shimon? Because time is so fast that we started it today.
Yes, that's correct.
Yeah, so what it is all about? It is exactly about what I covered so far. So while because the book is something that I treat kind of academical thing, like the book is full of knowledge. You have a lot of theory here. We have a lot of internals about .NET GC, diagnostic tools, programming tools, everything. That's a kind of the thing that you need to have a holidays, like 1 month of holidays, to read, consume, and try to use. And I'm fully aware that it is pretty problematic. I know a lot of people saying, I started to read your book, but I don't know a lot of people that were able to finish it. Like, it is a lot amount of knowledge. which is a lot of pages to cover. So online thing like .NET Memory Expert course that I provided, I believe is really, really nice because it has different structure. And it is all for covering those 3 levels that we set. So it is for, I really try to design it for everyone, especially for people that are afraid they are too, let's say, they are on level 0, let's say, they don't anything, and maybe they will be not able to understand. No, because it is for them too. We are starting from the beginnings to provide you all these caveats to understand those basic sanity checks, those abstractions that may leak, and some basic things that you can apply from in your everyday programming, everything to give you this gut feeling about .NET memory management. This is not the course that will make Ben Adams from you. Sorry. It requires years of experience writing code, low-level things, that obviously this course is a perfect beginning, but not the end. Although, because maybe you know me, I like advanced stuff. So I'm also covering level 3 because I really would love to see people that are advanced in this course. So advanced C# topics, some internals here and there, to satisfy also those people that are looking for some more advanced stuff that's just saying some basic stuff. So all those 3 levels will be here, interleaved with each other, interleaved with practical stuff, and diagnostic scenarios. And moreover, I especially made these .NET GC internals free on YouTube to be not tempted about talking about .NET GC internals too much, because I really like .NET GC internals and I believe they are super important. But on the other hand, although they are super interesting, sometimes the level of the knowledge that I present may be not necessary for everyday .NET developer, even on the level 2. So everything about that is there, and this particular course covers only these parts that are really important, that may leak at the level that is just good enough, not being too deep, not to overwhelm with not necessary knowledge. So I believe this course will be super balanced for practical usage. Like the practical is the main word that I would see when describing this work. Practical code, good practices, practical measurement, practical troubleshooting, examples. Although I'm a little bit afraid because providing good example of such advanced stuff is not trivial. Sometimes you need to write an app that resembles a real business app because you just need to provide a good troubleshooting scenario, but I will take it. And that's all. That's the goal. Provide you the knowledge to cover all this, to move you from level 0 or 1 to level 2, and to start to introduce you to level 3. I will cover nice things like stackalog, and span and ref. Obviously that is all there, but not all the time, because I believe we need to remember about this Pareto rule, we need to remember about this 80% rule, and these 2 perspectives about library authors and application development. So this will be somehow balanced to cover you and introduce you, to leave you with knowledge what the span is, how you can benefit from it, and that will be also there. But don't be afraid that, maybe you know me, I will be talking about span all the time. No, I will not. Like, I really want to provide you good knowledge at the level of everyday C# code. And that's in general mostly all. What I'm covering here, I will show you just my board when I was developing the whole course. So in general, one of the questions that may arise, what is the difference between the book and between the course? Whether I should buy or look at this course at all if I read this book, which is, by the way, congratulations, but whether you should, whether you benefit somehow. So I believe so, because as I said, the book is kind of academical thing, like everything is put there. The workshop is something like the book 2.0. So it is just the I once and I was doing it for a few weeks. I put every topic that I want to cover, put it on the board, and totally randomize it to regroup it again. Like, just forget how the book was written and now start to organize it from the practical perspective. Change the order, change the topics, rename things, just to provide the similar amount of knowledge, but with all flavored with practical approach, and probably in a different in a different order, because in case of the book, the order was driven by theory. I was just explaining in general automatic memory management, then I was describing what is the mark phase, what is the compact phase, and so on and so on. But for you as a level 1 or 2 programmer, you really don't super care about the mark phase. Like, okay, it is nice to know what the mark phase is, but what you care more is, for example, that you want to know what a memory leak is and how to diagnose it. So that's the main difference, the totally changed point of view from the theory to be a practical one. And then I have all those topics here, and it coined the whole structure of the whole course in the end. So I will not waste the whole time here for showing you all those stuff here, but in the end, I believe I created kind of the agenda that covers it in a better order with better practical approach, getting rid of theory. As I said, there will be a module about theory, but limited one, just for the purpose of the necessary, just with the necessary stuff that should be covered. And this is something that I'm really satisfied. Like, I know your needs, and I'm not saying here because I was doing workshops not once or twice. I know what are people interested in. I know after all those workshops, which were on-site workshops in the pre-COVID times, what are people interested in, what are the questions, what I should add more, what I should reduce. So this is the second difference. The book is after 2.5 years. Now we are 2.5 years after the book publication, and like 20 workshops that I gave about this topic for live people, talking with them, discussing with them. So I know what are developers looking at, what are you interested in. And this course gathered this knowledge, which helped me to restructure the thing to make it more practical. Which, by the way, makes me a little bit worried, because now when I will be writing the second edition, I will need to probably rewrite and at least restructure pretty a lot. But it will be in at least 2 years from now, because I don't have enough processing power to do that. So this is the course, and the goal is here. What I would like to present you is this particular approach about particular stuff. We will start from the .NET Runtime Basics. We need to talk a little bit about the stack, passing by reference, passing by value, and so on. That will be there. Then we have some fundamentals about .NET memory management in general. But they are pretty much important fundamentals. Like, for example, what are the GC modes? What GC modes should be chosen for various scenarios? How to set them? How to diagnose and measure whether your GC mode is good or not? Those are fundamentals, but super important ones. What are the latency modes, and so on and so on. Then memory leaks, roots, generations, everything about that is a separate week. And in general, the whole structure is like week-based, like in our different courses. So we have 9 weeks of knowledge. Every such week will be around 2-3 hours of lecture, plus your homework to be done. And I believe it is a lot of things to be there. By the way, so we will have the memory leaks, we will have some internals covered. I need to add some internals. Allocations, super nice things. Shimon is not allocating before noon. I'm allocating at all. But how not to allocate? How to measure where you're allocating, where to put your first gut feelings and knowledge, where probably you will benefit more. That will be there. Lifetime management, because there is pretty a lot of concerns and confusions about that. And then we will move to more advanced topics for these people that are starting to move from level 2 to 3, about span, unsafe class, pipelines, although it is not so super advanced, but I mean from API perspective, but to understand them, we need to cover some more advanced topics. Then a separate week about data-oriented design for you, because I really believe it is worth to know it. I don't expect everyone will use it on an everyday basics, but it is super nice and it opens your eyes for many things. And this knowledge obviously will be beneficial for you in this 3%, for example, scenario. And in the end, interoperability, because it is also something that is in .NET for years. And then we can pin things, we have fixed keyword, we can use memory mapped files, for example. Not everyone knows about that. We can move things off the heap. So sometimes it is wise to consider in your particular use case not to use managed heap at all. A lot of like that for people interested in, let's say, immediate advanced stuff. So a lot of these things, which is covered there, seems to be only 9 weeks, but it is a lot of knowledge, believe me. I'm super happy to be preparing all this stuff, and the most thing that I'm expecting to let's say take time now is to prepare all nice practical examples to show the things, to give you exercises to practice, troubleshoot, measure memory leaks. It is not trivial to provide nice memory leak. Like, obviously we have some, but typically the memory leaks are hiding in all those small implementation details of particular library. So it is super, super nice. So if you like to have it, go to the site, look around. Maybe you will find it interesting, as I hope I tried to convince you that it will be beneficial for you. I don't know, Shimon. I was trying to convince people. Maybe you can add something, because I'm running out of ideas.
Yeah, I think you did a great job. Please take a look at the site. The pre-sale, as we started it today, it will end on Friday, 8 p.m. Central European time. So you have a bit of time, but at the end of the week, we'll garbage collect the page and it will become only read-only, no more accesses. So please take a look, and now we'll have some time for some questions and answers, and hopefully we'll get some of them. So I will just go through the comments, because I think that some of them we already answered, and I will select them, and Konrad will take some time for answering them. So first was from Konstantinos, and it was related to the difference between the course and the book, and I think that you covered that in depth. So
I hope so.
Yeah, let's say that that its end. That was the one. Another one from Konstantinos related to huge memory issue with the app consuming 12 gigabytes. And I mentioned that was probably quite similar to the scenario that you provided and covered with the huge both second gen and log allocations.
Yes, because in general, also you need to understand the concept of aggressiveness of the GC. So people are pretty often concerned about the huge memory usage of the application, and it may happen because GC is always pretty not eager enough to collect memory, and it, for example, from the perspective of the GC, it believes there is a lot of memory in the system, but your opinion might be different, and then we have this conflict, and we need to try to analyze why the GC is not releasing things.
Cool. I'm trying to do my best to filter out the questions, so bear with me, please. And sorry if I missed something, but that was the second one related to the 60 gigabytes of RAM. And can we just ask GC to never perform GC at all? That was similar to the project that you had, right? The no GC allocator. What was the name of it?
Zero GC.
Zero GC.
It was called Zero GC, which was just only allocating, not releasing memory at all. Because, by the way, you can exchange GC in .NET since .NET Core 2.1, so you can do that. So, but returning to Simon's question, can I tell the GC that it is fine to use 60 gigabytes so that it is really never? So, in general, there is something like GC hard heap limit, the configuration knob that you can provide to the GC, which allows to configure it. What is this hard limit that GC sees? And by it you can control the aggressiveness of the GC. You can increase, you can decrease. So if, for example, you have a lot of memory available in the operating system but want to make a GC more aggressive, you can reduce this limit and make it seeing less memory available than there is indeed, or you can increase it to the opposite way. So you can control that, for example.
Okay, I think that this answers the question. I'm trying to do my best to run my where link query against all the questions that were put in there. So that was another one from Miłosz related to the I disposable and I async disposable. And I think you cover that in the course, right?
Yes, for sure. This lifetime management part will be covering that, because there is a lot of confusion about disposable and careless usage of finalizers, when you should use finalizer, where you shouldn't. Now we have the second layer of this confusion because we have the async disposable. So even making things more complex. That's, by the way, nice topic for a blog post, for example. So I will think. For now, I don't have anything at hand ready. So for you, Miłosz, but I will think about it. We will return to that. So you can follow me on Twitter or here on YouTube. Maybe I will make a GC tips and trick webinar about that. For sure, I will cover that in course too, because it is the heart of the lifetime management.
Awesome. Another comment from Voldek related to the, by the way, quite a nice picture for that, for your account. It's pretty, in general, it's pretty hard to hurt your career by learning more. And I think that was mentioned when you were discussing the advancement in one's knowledge. And the other counterpoint, sorry, but that made me laugh hard. You will be less popular if you start talking about GC internals at parties. But we do not encourage this kind of behavior, and there won't be lesson covering GC-related jokes for parties, I believe, but we can add something if needed.
If there is a demand, we can add for sure.
Yeah. Oh yeah, quite an interesting one from Cozy Lord, that the high perf C# component will be much easier to integrate with the P invoking, and that was something that you mentioned and covered as well.
Exactly, it's not without the cost, so that's true. I fully agree.
Another one interesting to know one level down, to know something one level deeper than the abstraction. Quite an interesting one as well. Just doing my best to scan through. That's an interesting one.
Use the for each loop. Yes, so, more performant code is less maintainable. I agree. In general, it pretty often, but not always, is that performant code contradicts clean code, because clean code is for maintainability, to be nicely read and changed, and then performant code typically is containing a lot of those strange little not so easy to understand magical tricks. I agree, and by this is not always true. Like sometimes you can even read that. I mean, C# is always also super nice in providing nice abstractions, by the way, again, to write low-level stuff. Like we have unsafe class without, but still probably for some it will be less maintainable. But my point is here mainly that not whole application is written that way. So we have this 3% that we can separate, and it is even better for the perspective of the whole structure of the application. Like we separate aggregates, domains, contexts. Then we can also separate a core of our performant code, make it as a separate thing. It's even better because then we can benchmark it with the help of benchmark.net. And this is the part that is just to be maintained a little bit more harder, but still some people will understand it. So I believe by separation of good and by good structure, we can handle it. The worst thing is that we can spread this kind of code through the whole application, and then we have unsafe endpointers in the web controller. That would be probably a little less good thing to do. But yeah, I don't know how your view is, Shimon, on that.
I think that we have a good usage scenario for these kind of techniques in the .NET runtime itself. And if you apply modern techniques like unit tests and benchmarks, and you have quite a good coverage, and I don't mean that I mean like 100, but again, you cover what you are doing with tests, then you are more likely to make it maintainable. And if you keep the separation that Konrad mentioned, that only will it will add up and create a possibly more maintainable code base.
Exactly.
We've got a question related to .NET diagnostics. So that's a separate course that Konrad mentioned at the very beginning of the course. So the best answer to that question is please do subscribe to the mailing list. Sebastian provided a lot of knowledge in there on the landing page of this course, and we'll do our best to open as soon as possible. That's a good one. So from Paul. We are allocating as many actors as possible, but
I'm waiting too.
Yeah. Another one. Okay, so another mention of 2 kilograms of of the book. That's a good one. So will the person who read the book, will they benefit from the course?
Yeah, so I try to answer it a little bit. I believe so, for sure it will, because as I said, it is like the same book, written, restructured, with the addition of the whole experience of making .NET memory workshops on site with people and .NET developers, and put into the video form, concerned about practice development. So, and getting rid of theory, which is a kind of nice thing, but not having too much theory, not to overwhelm you with not necessary details. So for me, it is pretty a different thing. Like, even if you have read it and you probably done this like year ago, you will benefit a lot. And this is the for sure that like this is something different. And moreover, there will be homeworks and there will be troubleshooting scenarios that will be, I will spend a lot of time preparing them. So they will be typically not kind of console app with a single while loop inside. And one more thing is that this book was at the time of .NET Core 2.1 with some upcoming announcements what will be in .NET Core 3, and now we are at the time of .NET 5 with announcements what will be in .NET 6. So also from this perspective, it is updated simply because there are constantly going on changes in the .NET, also on this surface with the memory management. So all those things also will be there.
Yeah, I'd like to add that beside all the content and all the approach that Konrad mentioned and the migration to the .NET, also with the course comes the community that we recently started, and we are doing our best to migrate all the attendees of our courses and engage them on the community, on our community. So that's another great place to have an interaction about the content of the course, and as the already called .NET Diagnostics related course approved, there is a lot of interaction both between the users and the course author. So in that case, Konrad, so a lot of good exchanges and a lot of good vibe and information exchange is happening actually in the community that is again included with the course. There is a question related to the when will the course start? So we are aiming the third quarter of the 2021. That's the overall approach. And how does it work? It's the structure is similar to all our courses. So every single module is provided every single week. We publish the new module on Monday, and you have access to all the modules. So if you want to take a break or allocate a huge array and just have fun with it, it's up to you. And you can do it in a self-paced, asynchronous manner. We don't want to chase you, but we will encourage you to learn from it, to share your findings from your homeworks, and to just be engaged and learn a lot. How many hours per day? I mean, Konrad already provided some stats, right? Like 2 or 3 hours of recordings per week. So that probably depends on you, how much you want to spend and how much you want to dig into the homeworks. But I would assume that basically, if you want to just watch, that would be 2 or 3 hours per week. But as always, we encourage to dig a bit deeper, to try to follow the homework and to try yourself against the specific task and share your findings in the community.
Definitely, because like watching something, everything seems to be easy and understandable, but then you start to investigate it on our own and on your own, and you don't know where to start. So I believe doing those homeworks will be a really important part of the course.
Mm-hmm. There's a question related to the, are there any plans to put your course to Pluralsight or similar learning platform? So we have our own academy, and we do our best to make it as great as possible. That's why, for instance, recently we migrated to the new community that is much easier to follow, much easier to create new topics, to have longer conversations, to quote code snippets and paste them and have discussion on top of that. So we are doing our best to make the learning experience as best as possible. And again, if you compare the overall amount of the content and the interactions that we provide, that is something undoable with the Pluralsight courses. And I mean, probably it's apple to oranges, but we aim at delivering a huge amount of material in a really well digestive form, and both support you with the live meetings and the already mentioned community support with our new forum. So the answer is that we already have that platform, so you need to join us to get this one. Cool. I'm just looking.
Garbage collecting every comment, which is not a question.
Any GC pickup lines? That's a good one. Probably I'm the person responsible for bad taste for humor and jokes, so I will do my best to provide one or at least one generation of such lines. Cool. Yeah, I think that's I'm sorry if I skipped some of these, but there was a lot of comments. I tried to did my best to apply the query in there. So, Konrad, do you have something?
If you have any more questions, now is the last minute. Like we have kept you for almost 2 hours already. So, so there is, I think, on the chat something about one of the.
That's the last one, probably.
Okay, so advanced C# tips for Voldek. I'm not sure how to pronounce your. So this is all about about using span, using stack alloc, using refs, ref structs, and build on it pipelines and unsafe class. So things that typically you are not interested in your app, but you are starting to become more and more interested when you are writing your library, like parsing strings, serializing binary data, reading binary data, sending through network, everything which will be about that. For example, I have a huge amount of interesting things about refs, because I'm not sure if this presentation is available somewhere, but I had some talks about refs. You have ref as a general concept in C#. You have ref structs. You have ref as passing as argument, ref returns, ref ternary operators, ref other stuff, ref structs. I'm not sure if I said that. So a lot of things, how you can utilize passing by reference to the next level. So that's all. All things are covered like that. Span, memory.
Yeah, so I think that let's assume that that was the last question that we can cover. We strongly encourage you to take a look at the landing page of the course. As I mentioned before, we just opened the pre-sale. We are ending it on Friday, 8 p.m. Central European time. Summertime probably, and we strongly encourage you to take a look and visit. If you have any questions, remember on all of our pages there is also always this icon in the right corner where you can follow up with any question that comes to your mind, and we'll promptly answer and do our best to cover everything that comes to your mind. So
yes. And one more thing, because this is a huge topic for sure. So if you will feel when doing this course that some question is not answered, remember a thing that Shimon mentioned, there will be community. So the questions may be asked also. For example, I will be describing some things, how the memory works in the .NET GC internals lesson, but you will be not satisfied with the level of the deepness of it. For sure, I will refer you to materials, my talks, or I will answer directly with some more details. So it is not like a book that you buy it and you have 1,000 pages and that's all. There will be just this interaction on the community that helps. And I really believe it will be also a good benefit.
Yeah, I think that already the .NET Diagnostics people
Shows
that gather
that,
around
exactly,
this course,
exactly.
It proves that it's working pretty nicely, and we will keep on working on that to make it even
Recently,
better.
I saw there a topic where they were debugging a debugger to solve some issue.
Okay, that sounds like a Sebastian stuff. Yeah, cool. So thank you for being with us today. Have a good evening, and please visit the page, take a look at what's there, and thank you for being with us again.
Thank you.
Take care.
Thank you. Take care. Bye then.